And we're back to learning JavaScript. This is already the third section here in the JavaScript curriculum. It's regular expressions, and regex or regexp is used as an abbreviation for that. So we're going to stumble over this term. Let's just dive right in with the first one using the test method. So we can use this, for example, here to test this test string freecodecamp. In this case it returns true, so a test method always returns true or false. Let's check this example. We have a string, the dog chased the cat, and we want to find if the is inside, and this is what we do with the test. In this case we test if the test string has the test regex code inside of it, and this is true because that's part of freecodecamp. Let's apply this to our example on the right hand side. We've got my regex, and we want to test my string if it has my regex. So my regex is set to hello. We use .test and we apply this method to our myString variable right here. So I copy paste that and we should be good. So it is tested if hello is part of my string, which is hello world. So this one would return true. We want to match literal strings here. So we've got another test. In this case, test string is hello, my name is Kevin. Kevin is the regex, and if we use test, it will return true. But if Kevin was written with a lower case k or in all uppercase letters, it would be false. So this is case sensitive, at least the way we've written it for now. So in the second example right here, wrong regex, Kevin is spelled with a lowercase k, and therefore it will return false if we test it. Let's jump to our example on the right hand side. We need Waldo, and it's a literal match, so it's uppercase W. Are we good with this one? We can get around this, for example, by using different possibilities. We've got the OR operator. And here in the example we can write yes or no, or yes, no, maybe. So you can have multiple possibilities used with this OR operator. We want it for our pet regex, set to dog, cat, bird, or fish. And you just need to have these lines, these vertical lines in between, so that way our test method knows that we're going to use these different values for pet. Let's go ahead to ignore case while matching. And we introduce two flags. In this case, I is a flag that's used. You can add that to your regex after these backslashes, and therefore it will ignore lower and uppercase. So in the example on the left hand side, we've got ignore case, and no matter how it is written, as long as we've got the flag I added, we're good. And we do that for freecodecamp here as well. So I paste it, and afterwards we've got the I flag. We can move on. Extract matches. So up until now we've used the test method. We can do almost the same using the match method, but it's going to extract. So we're not having a boolean true or false returned via tests. In the example here, we'll use our string regular expressions, and expressions would be returned by the match method. So it doesn't give you true or false, it gives you what you're actually searching for. You have to be careful here. So the way to write it is a little bit different. It's the opposite when you compare it to test. So for test, the regex comes first and then the string, and for match, it's the string that you're testing first and then the regex. In our example on the right hand side, we'll just add coding right here. And then in the third line, we'll add the match with our regex inside of the parentheses. So in this case, we would test if extract string has the coding regex, which is set to coding. Let's go to find more than first match. So sometimes a string has the same value over and over. For example, here repeat. If we just use our regex like this, we would have only one repeat returned. We can add another flag to it to change that. So if we use the G in this case, we would have all 3 repeats returned. In this case, we want to have twinkle. We want to have them all returned. So if we write it like this, we would only have the second one returned because it has the lowercase t. If we add an I to it, we would only have the first one returned. So we need I and G. So both flags should be used here. You can have multiple of them in your regex. So the way it is written now, we would have returned 2 twinkles, the first and the second. Let's move on to match anything with a wildcard period. So this is simply a dot or period, and it's basically a placeholder. Go over the example right here and it becomes more obvious what it is. So we've got hug, ha, hut, and hum. And if we have a regex of hu, which is always the same in these cases, and then add the dot is a placeholder for any of these letters. So hu dot would be true for all of these examples. We want to do the same on the right hand side for our unregex. And it should match run, sun, fun, pun, none, and bun. So second and third letter are always the same, but the first one is different. Therefore we'll start with the dot and then add un to it right here in our unregex variable. And then we should be good. Match single character with multiple possibilities. So here we're going to use the square brackets. They come in handy when you, for example, want to compare bag, big, mug, and bog. So you want to have not the dot, which would make all of these cases true, but you only want to have specific cases. So in this example, A, I, and U, that means that the last one, the bog string, this would be false, and all of the other ones, they would be true. And when you use match, a false case would return null. So this is what you use the square brackets for. Let me check the example for the right hand side. We use the vowel regex to find all the vowels in the string quote sample. We need to quote sample.match. Inside of the parentheses our vowel regex. And we'll add the square brackets and then the vowels. Oh, I've got a typo right here. So let me correct that. There's one bracket that I don't need. And we need to match both upper and lower case. So we also need the I flag. And I've missed something else. Let me check. And we want to find all the vowels. So not just one. Therefore we also need the G flag. We'll add it right here. And now it should run. Match letters of the alphabet. So we can also use these square brackets to define a certain range, in this case for letters, so A up until E. We can use it also on numbers. Let's stick with the alphabet for this one. We want to match all the letters in the string quote sample. So here we've got the quote sample, and we need dot match, and then the alphabet regex. And we want to change that to, we want to match all the letters, so A to Z inside of the square brackets. We want to match uppercase and lowercase letters, so we need the I flag. And once again, we want to match all the letters, so we also need the G flag. So I've forgotten that, but now we should be good. Match numbers and letters of the alphabet. And here the numbers are introduced. As I've said, we can place them in the square brackets as well to define a number range. Here on the left hand side we've got A to Z and 0 to 9, which would be all the numbers and all the letters. I for the uppercase and G for finding all of these characters. On the right hand side we need a single regex. Let me check, quote sample dot my regex. And this one should have a range of letters between H and S, and a range of numbers between 2 and 6, so 2 minus 6. Remember to include the appropriate flags. So we need G and I. And we can move on. Match single characters not specified. We can use this caret character. You will find it at the top left on your keyboard, at least I find it there. So it's basically the opposite. So a negated character set. In this case we've got the vowels and the caret is before it. And keep in mind that also dots, exclamation marks and a white space and such, they will also be counted if you want to, for example, use a match method. Let me check what we have to do on the right hand side. We need once again a quote sample and apply match to it with my regex, and my regex should match all characters that are not a number or a vowel. So we need this caret character. Not a number or a vowel, so 0 minus 9, and then all of the vowels added. It should match all characters, so we also need a G and an I flag. Oh, let me check. I've got a typo right here, but now it should run. Match characters that occur one or more times. So we can use the plus sign to check if something is there once or multiple times. So in this case, A plus would find one match in ABC and return the A. But it would also find AA in AABC. And in ABAB, it would find the A 2 times, because the B is in between. So it will give you an array as a return. And in BCD it wouldn't find anything. Now let's go over our example on the right hand side. It's about Mississippi, and we want to find matches when the letter S occurs one or more times, so we'll use this plus character. You can directly go to the second line and change the regex here. So we need our S, and then the plus character. And don't forget to add the G. Match characters that occur 0 or more times, so that's the difference between the plus sign and the new character that's introduced, which is the star or the asterisk. So the asterisk also finds it if it occurs 0 times. So here's an example. Go with the asterisk, and Soccer World would give you G and then a couple of times this O. The G phrase would return G, because the G is inside, the O isn't there, but thanks to the star character, it is still found because it's 0 or more times. And only a third example, the O phrase, it doesn't have a G, therefore this would return null. If we would have written GO plus, the second and the third phrase would have returned null. So that's the difference between plus and star. Let me check what we have to do here. On the right hand side, we need to match an uppercase A, immediately followed by 0 or more lowercase a's. 0 or more, so we need the star icon. We don't need any flags in this case, so we're good. Find characters with lazy matching. Read through it yourself. I go over this example here. It's Titanic. Let us read the first regex. It's T and then all the letters in the alphabet and the star. And afterwards an I. So we would have returned Titani in this case. But if we use a question mark, it is changed to lazy matching, so Titanic would only give us T and I. So without the question mark, it finds the largest possible pattern, and with the question mark, it finds, you could say, the smallest possible pattern. So explained in easy terms. We're going to go over the right-hand example. For now, we would have returned the largest pattern, which would be the entire tag right here with winter is coming inside. But if we add the question mark to it, we would only have H1. So we'll have to put it right here after the star icon, and then we should be good. Find one or more criminals in a hunt. So our regex in the example on the left is Z+. It would find matches in all of the first 5 cases. So Z to ABC and then multiple Z's ABC. But it doesn't find matches here. So where it's empty ABC or ABC ABC. We want to do the same here. So our regex needs to be capital letter C. And then we need a simple plus sign, and then we should already be good. So it's one or more criminals. Match beginning string patterns. So this might be a little bit confusing because here's this caret character again, but this time it's not used inside of the square brackets, and then it has a different meaning. So here in the example on the left hand side we've got Ricky, and the caret is before it, therefore it searches for the beginning of the string, and it finds it in Ricky is first and can be found. But the not first string, so the fourth code line on the left, it has you can't find Ricky now. So Ricky is not at the beginning of the string, and therefore it's not found anymore, and our test would return false in this case. So this is what the caret does when you use it outside of these character ranges or character sets. Let's go over this on the right hand side with cal. So if cal is at the beginning, we want to find it. So we need the caret character and then cal. And we're good here. Match ending string patterns. So you can also find things that are at the end of a string, and you can use the $sign for that. So it's basically the same as the caret, which was for the beginning, but the $sign is for the end. So if story is the last word, it's going to find it, but in the fourth code line on the left, the no ending story is not the last inside of our string, therefore this would return false. Let us edit right here on the right hand side, caboose and the $sign. So if the word caboose is the final element of a string, it's going to return true. If it isn't, it's false. Match all letters and numbers. So you can define your character sets specifically, but there's a shorter way to write it, and this is \W. So \W basically means all uppercase and lowercase letters and all numbers. So this has the same meaning. Let me check what we have to do on the right hand side. We use the shorthand character class to count the number of alphanumeric characters in various quotes and strings. So we need \W, and we need the $sign. And don't forget to add the G, because we want to count how many are there. Match everything but letters and numbers. So there's, let's say, an inverse of this \W, and this is the uppercase W. So it's basically the same as using the caret inside of the character set. So once again, this has the inverse meaning, you could say. So everything that's not uppercase or lowercase letter and not a number and not an underscore would now be true. So in the numbers variable we'll find the percentage, and in the sentence variable we'll find the exclamation mark. And all that we have to do here is to edit in our non-alphabet regex. So instead of using the caret and all of this and all of these character sets, we'll simply use / and then uppercase W. We want to count it, so don't forget to use the G flag. We want to match all numbers. So a shorter way to write the number character set 0 to 9 is the \d. Once again, we want to count something, so we need the G flag right here. And the inverse would be the uppercase D. We want to use that here for match all numbers. We want to use that here for match all non-numbers. So \d, count how many, so we need the G flag. Alright, here's a more complex example. It's restrict possible usernames. We've got 4 bullet points or 4 tasks our regex needs to fulfill. Usernames can only use alphanumeric characters. Only numbers in the username have to be at the end. Can be 0 or more of them at the end. Username cannot start with a number. Username letters can be lowercase and uppercase, so we need the I flag. Usernames have to be at least 2 characters long. A 2-character username can only use alphabet letters as characters. So we need to define 2 cases. The first one would be A to Z, and then A to Z. So this would be for 2 characters. It can only use these letters. And lower and uppercase, I've already dealt with that by using the I flag. Only numbers in the username have to be at the end. Let me use the caret right here. It has to be outside of the character set, which is the important step, because we want to search for the start of our string, so not the inverse of A to Z. What else do we have to do? We'll have to use the numbers. They can only be at the end, so we need the $, and we can use this \d, which stands for 0 to 9. There can be 0 or more of them at the end, so we'll use the star. Username cannot start with a number. We've already dealt with that. But we also need the +, because we might have more than just 2 characters. So this would be the general case, but we need a second case. So I'll use the OR. Then again, we want to check first the A to Z. And then there might be a number, but it definitely has to be more than 1 number then, because otherwise it would be a 2-character username, and this is not possible when there's a number involved. So we need the \d once again. It could be multiple numbers afterwards, so use the +, and we need the $, to make sure that the number is definitely the last character. And now we should have all of the cases covered. If I haven't made any typos here or misread something. Let me run it, and we're good. So this would be the solution. As I've said, it's a little bit more complex. Maybe you want to pause the video and read over it once again yourself. We'll continue to match whitespace, and we can use \s for that. In this example, here on the left hand side, we've got 2 white spaces, and they would be returned if we use \s with a G flag. Without the G flag, we would only have one white space. It would also count tabs, for example. And here we just need it with a G. And once again, we've got the inverse, which is the uppercase S. An example on the left-hand side, we would count the length, and the length would be whitespace dot, then whitespace, then everywhere, exclamation mark. So what do we need here? We need backslash uppercase W. Let me check. Obviously we need uppercase S. So I got confused here. S is for the white space. So it's uppercase S and the G. Let's move on to specify upper and lower number of matches. We've used plus and asterisk so far, but sometimes we want to specify a certain range. So the example on the left hand side, we want to check A if it's 3, 4 or 5 times in our string, and then if an H follows. So let A4 would be true, but let A2 would be false, because A is only 2 times in there, and our range is 3 to 5. On the right hand side, we need the O regex for or no, and only when it has 3 to 6 H letters in it, it should be true. So let us first write or no, and then we use these curly brackets after the H and the final range. It's 3,6. Specify only the lower number of matches. So I can also set it so that you don't have a fixed range on the upper limit in this case. So it's just 3 comma on the left hand side. So whenever there's an A 3 times or way more than this, it's going to be true. So let A2 would be false, but let A4 and let A100 would be true. Let's do this for Huzzah. When it has 4 or more Z letters. So I can delete one Z and add the range 4 and then a comma. Specify exact number of matches. So when we don't have a range but a specific number, we can just leave out the comma entirely and just add the number that we are searching for. So in this case, it would be a 3, therefore let A4 and let A100 would be false, but let A3 would be true. We'll do the same for timber, but only when it has 4 M's. So curly brackets after M and then add 4. Check for all or none. Here's the question mark again. We can use it to check if a character is there or not. That comes in handy. For example, here when we switch between British and American English, for example, the word color is written differently, and a question mark after the U, it would simply say that if a U is there, it's true, but if it's not there, it's also true. Same goes for favorite, so we'll add the hue for British, and then a question mark. So in American and British it will be true now. Positive and negative look ahead. Once again, read through this yourself. Maybe you want to pause the video, it's a little bit more complex. Let us check the examples. So we've got quit and no quit as strings. And we've got a positive and a negative look ahead. The first one, the QU regex, has a positive look ahead. So it would give us the Q as a return, and the second one would also give us the Q because it has a negative look ahead. Maybe it becomes clearer if we use the second example right here. If the password would be ABC123, we would check right here with the positive look ahead. A certain range of 3 to 6 characters. We have that. And it should have at least one number, which is the second parenthesis right here with the positive look ahead. If you see this for the first time, it's a little bit complex. Pause the video, try to understand it a little bit better by reading over it a couple of times. I will simply solve the problem on the right hand side and explain it. So what we need is the PW regex. So we want to match passwords that are greater than 5 characters and have 2 consecutive digits. So we'll use 2 parentheses. We'll use the positive look ahead, \W, and the range is given. It has to be greater than 5. We can simply use 6, as it has to be greater than 5. And the second condition is it has to have 2 consecutive digits. So again, positive look ahead. And then we'll check if there are at least 2. So we use \D with a range of only 2. Check for mixed grouping of characters. Here's the OR operator again. So we can use it for penguin and pumpkin. And we'll then replace the middle part. As start and ending is the same for both words. So you can define multiple options you could say for the regex with this OR operator. And the example on the right hand side is for Roosevelt. We've got Franklin and Eleanor. And I believe it was Franklin D. Roosevelt. I don't know what the D stands for, but it's possible that there are middle names. So we'll have to make sure that we get that covered in our regex. We'll have to change the third line as well. Let me paste the regex. We want to test it, so true or false should be returned. And we use myString. So this should be code line 3. Let's go to the regex. We can directly type in Franklin or Eleanor. It's inside of these parentheses. Afterwards, we'll leave a white space and then another parenthesis for the middle name. and we'll use A to Z. We don't need any numbers or anything. And afterwards it could be multiple. And in the case of Franklin D, it would just be one letter. So we can write it like this, \dot question mark. Then or, and once again A to Z, and then A to Z lowercase, and afterwards a plus sign. So this could be a full name and not just the letter D. Then once again a white space. Don't forget that. And now we need the last name. So question mark Roosevelt. And now it should work. So let me go over this again. We've got Franklin or Eleanor as the first name, then a white space. Then we'll check if there's a letter. So in the case of Franklin D. Roosevelt, this would be true, or a middle name. So whatever the D stands for, maybe it's spelled out completely. We've got that covered with the or right here. And here you can see it, we need another white space after the D dot, and then the last name Roosevelt comes. So we're good to proceed. Reuse patterns using capture groups. Let us just go over the example. It makes more sense to explain it like this. We've got repeat regex, so \w plus for all of the words, in this case row, and then \1 if we've got it repeated. So the match would give us an array in this case of 3 times row, which is the first element, and then a single row. And on the right hand side, we need to use this capture groups. We want to check if the same number is repeated exactly 3 times. So in this case we've got 42 and then \1. But we also want to check it for other numbers, so not just the 42. If it's for example 100, it should also work, therefore we need to write it differently. You can see for example here, 42 3 times or 100 3 times, there should be true. Therefore we need these parentheses inside \d for the numbers and plus, so whatever number there is. And then we need \1 We know that it comes 3 times. And we need the $sign right here to make sure that the second repetition, so the third times the number is displayed, is the last one. And let me also add the caret, which is going to be the start. And now we're good here. Use capture groups to search and replace. So now the replace method is used. So sometimes you want to search for something and then directly replace it. In this case, we've got the wrong text, the sky is silver, and we want to replace silver with blue. So the regex, it checks if silver is part of the string and then directly replaces it. And then a replace method directly replaces it with blue. You can also reverse word orders like this. So we've got that right here, W plus, then the white space, W plus. And this would then be reversed with $2, $1. So code in this case is $1 and camp would be $2. Instead of code camp, we would have replaced it with camp code. Let me check what we have to do on the right hand side. So we want to update 1, 2, 3 with 3 to 1. So our replace text is going to be 3 to 1. And our string is 1 to 3, that's already given. Therefore we have to change the replace text to 3 to 1. And it's a typo, let me correct that. And the regex is going to check if we've got 1, 2, 3. So we use the parentheses and inside \w plus, then \s for the white space. And again parentheses, \w plus for the next word, \s for yet another white space, and a third word, again \w plus. Now we should be good. And now we want to use the dollar signs in the syntax, so the replace text has to be different. Instead of 3 to 1, we need $3, $2, $1. So let me correct that. But now we're good. At least we should be if I haven't done any typos. Let us go over this again. So we've got our string 1, 2, 3, and the replace uses the regex that we've defined. The first W plus is the first word, and then the S is for the white space. Second word comes, third word, and we're going to reverse it with this $3, $2, $1. You can also remove white spaces from start to end, and we can do that by using this replace method. Let me show you how. We've got our string hello, and it has a lot of white space, then hello, comma, white space, world exclamation mark, and again, white space. I want to get rid of the white space at the start and after the exclamation mark. So at first we need to use hello replace, and then in parentheses we need our WS regex, and then we need to replace it with something. Let me just add that as a placeholder, and we'll take care of the regex first. We need \s, so we want to find the white space, and it has to be at the beginning, so we need the caret, and don't forget to add the plus sign, so if there's one or multiple. Afterwards, we use the OR operator, and then \s plus, and this time for the end, so use the $sign. So it's going to find the start and the end, and if there are white spaces, it's going to select it, and we want to replace it with something, and just add these quotation marks with no content, and now it should work. Well, let me check. I've missed something here. Obviously I have to add the flag G, because we want to find them all and not just one. But now we should be good. And this concludes already this regular expression section. The next one is debugging. So this is the next course section here on freecodecamp. We've covered a lot. Once again, read through all of this yourself, try to solve it yourself, and use my walkthrough whenever you get stuck. I try to finish the debugging for next week. In general, I hope this video was helpful. Thank you for watching, and I'll see you next time.